You are listening to Kubernetes Bytes, a podcast bringing you the latest from the world of cloud-native data management. My name is Ryan Wallner, and I'm joined by Bhavin Shah, coming to you from Boston, Massachusetts. We'll be sharing our thoughts on recent cloud-native news and talking to industry experts about their experiences and challenges managing the wealth of data in today's cloud-native ecosystem.
Good morning, good afternoon, and good evening wherever you are. We are coming to you from Boston, Massachusetts. Today is February 7th, 2024. Hope everyone is doing well and staying safe. Let's dive into it. This is, I can't believe we're already in February. January just flew by. I had a couple of work trips, one small PTO. So been trying to maintain this cadence. Obviously, hopefully you guys like the episodes that we have been bringing you this year. And I'm not making that great a progress on my New Year resolutions, but at least I'm tracking them this year. So hopefully you are doing better at those than I am at mine. Before we dive into the topic for today, we have a great interview lined up around one of the requested topics from our listeners. Before we do that, let's talk about a couple of things that are happening in the cloud native ecosystem. So in terms of news, we have two acquisitions. The first one being Dynatrace acquires a startup or a company called Runecast or Runcast, Runecast, right? So Runecast was a vendor that I came across when I think I went to VMworld or VMware Explore back in 2018 or 2019. They were a security firm that were helping build or helping provide like a security posture management solution to VMware customers. I think that Dynatrace acquiring them definitely helps them expand their contextual security protection and analytics platform and helps them bring those capabilities, the security posture management capabilities for the hybrid and multi-cloud environments. Personally, I also feel this gives Dynatrace a foot in the door for existing VMware customers, especially customers that are looking to modernize their infrastructure and application stacks as we are in the first quarter of 2024. Calendar 2024. But yeah, that was an acquisition. The price wasn't really disclosed. I thought we'll just discuss it since Dynatrace is a vendor that many people use or in the cloud native ecosystem. Next up, I think we have another acquisition. Chronosphere acquires Calyptia. I hope I'm pronouncing this right, guys. Calyptia was the original creator of the Fluent ecosystem, so FluentD and FluentBit. All of those open source tools that you see in the CNCF landscape, those were built by Calyptia. Again, I only found out about Calyptia because of this acquisition news, but again, it seems like an important vendor in our ecosystem, right? Because anytime when we were preparing for our certified Kubernetes admins or application developer courses, or whenever we talk about logging in general, when it comes to these cloud native applications, we think about FluentD running on our host set as a daemon set, right? So this acquisition will allow Chronosphere to add the observability pipeline product that was built on top of FluentBit into the Chronosphere platform, which enables routing, transformation, and optimization of log data at scale. So we'll link to the acquisition blog in the show notes or the press release in the show notes, so you can read more about like how these two companies are planning on working together going forward. But another exit for a startup in the cloud native ecosystem. Personally, I have a feeling that 2024 is going to be the year of mergers and acquisitions, if not IPOs. But we have been seeing a lot of mergers and acquisitions to start off the year. But I think I'm hoping for at least that the IPOs start rolling in the second half, so the third quarter or the fourth quarter of calendar year 2024. But here's to hoping, right? That's it for news today. I couldn't find anything else that's happening from any of the vendors in the product ecosystem. So we'll just keep it short for the news today. Diving into the topic for today, we are going to be talking with Jason from SUSE. He's the director of Edge Engineering. Again, a great participant in the cloud native ecosystem or cloud native community. I know he has done stints at Red Hat and Google Cloud and has been a vocal advocate for Kubernetes and OpenShift and all of the technologies that we love today. So we'll be chatting with him about K3s, what it is, how to deploy it, how it works, how the security and storage work, and all the good things. So without further ado, let's bring Jason on the pod. This episode is brought to you by our friends from Ilotil. Ilotel Luna is an intelligent Kubernetes cluster autoscaler that provisions just-in-time, right-sized, and cost-effective compute for your Kubernetes apps. The compute is scaled both up and down as your workload's demand change, thereby reducing operational complexity and preventing wasted spend. Luna is ideally suited for dynamic and bursty workloads such as dev test workloads, machine learning jobs, stream processing workloads, as well as workloads that need special resources such as GPUs or ARM based instances. Luna is generally available on Amazon EKS, Google Cloud GKE, Azure AKS, and Oracle OKE. Learn more about Luna at ilotel.co/luna and download their free trial at ilotel.co/luna-free-trial. Hey Jason, welcome to Kubernetes Bytes. Thank you for joining us for this episode to talk more about K3s. Why don't you introduce yourself and tell us more about what you do at your day job?
Sure, and thank you for having me. I'm excited. It's been too long since I've got to sit here and nerd chat with somebody, and I'm really excited for this. So my name is Jason Dobies. I am a director of engineering at SUSE. SUSE, known for a long time for our Linux distribution. A couple of years ago, purchased Rancher and a major player in the Kubernetes space. And then very recently, over the last year, we have built up an Edge department. I'm one of the two directors of engineering in that Edge department. We're looking to flesh out our portfolio and try to release something in the next couple of months. In addition to that, I'm an adjunct professor, which is a really cool sounding way of saying part-time. I teach software engineering in the spring and then senior projects in the fall. And I mention that now because there's a handful of times I may say something like my students. And if without that intro, it gets very awkward to picture me at work referring to them as my students.
Okay. No, I keep forgetting about the professor thing. So I'm glad that you brought that up. So some background for this episode, right? Ryan and I did like a Kubernetes at the Edge 101 episode where we spoke about some of the challenges that exist at the Edge and spoke about K3s and microkits and some of those solutions that are out there. And then we actually got feedback that, can you do a deep dive on K3s? And when I saw that you now lead engineering at SUSE around Kubernetes at the Edge, I was like, okay, perfect guy to have on the pod.
Yeah, so that worked that well.
Yeah, for sure. So let me start there, right? Like, I want to get your perspective. Like, why do you think Kubernetes in general is a better solution for these Edge deployments? Go ahead.
Yeah, so better is an interesting term there because it's interesting depending on what you compare it to. We're in a really fun space right now because there's really no incumbent. We're not looking to compete with something that's been around for decades and, SQL has been around for like 70, 90 years by now. We're not like that. We're in an area where the space is growing, but the solutions just aren't there yet. So when you say better, it's an interesting question because there's no real kind of incumbent that we're like, hey, we're going to take this on, we're going to replace it. But why is it good? There's a variety of reasons here. One of the things is that we have a lot of customers and a lot of people moving to Kubernetes in general for reasons I'm sure you have covered 1,000 times now on this podcast. So I won't dig too deep, but I will mention that being able to put it at the edge keeps the same APIs, the same deployment structure, keeps all of your knowledge that you're used to and lets you apply that now to the edge. So I'm certainly not about to say all of the problems are solved. And if it was, I wouldn't have a job and we wouldn't be having this conversation. But it does reduce quite a bit where your learning curve is not quite so huge because you understand how to interact. You understand this declarative model and how to say, this is what I want. And you understand, and you, of course, being the admin who is comfortable with Kubernetes, which in and of itself is different for your traditional admins who like to know every little bit and piece of where everything is running. That doesn't scale to the edge. So being able to rely on Kubernetes and say, look, just get this out there, keep it running, and tell me if something's wrong is a really, really nice incentive there. On top of that, you get all of the other projects and ecosystem around Kubernetes that, in varying degrees is applicable to the edge. Some of them are more heavyweight, but at the end of the day, a lot of the work you've done to certify for security and the hardening in your data center now basically gets transferred to the edge with Kubernetes out there. And you can fit it into a lot of your existing workflows. So at the risk of trivializing it too much, you basically get a similar API that you're used to working with inside a data center, but now it's going to bridge to all of these edge systems and all of these edge environments where you traditionally can't interact with them in a way you would with a data center.
No, I think I like that answer, right? Like the consistent API server experience, because in the past I used to work at Lenovo and we had like an edge solution, which was more hardware based. We had like a ruggedized server that we sold to customers who wanted to deploy like a 2-node thing. But then eventually talking to different customers and even at the same customer, different sites became kind of that snowflake environment, right? Like they didn't know what was actually being deployed or how it was being managed. Some were running virtual machines on top of like a Windows server instance. Some were running like bare metal applications. So no, I think Kubernetes definitely brings that consistent experience for sure.
Yeah. And holy cow, I just completely brain farted. So let's just keep moving.
Okay. So next question I wanted to ask was like, Kubernetes is great, right? Like, as you said, we have covered it 1,000 times already, but why did we need like a different distribution? Why couldn't we just take Kubernetes and run it at the edge? Why K3s?
Yeah, so I love this as a question because so much of this speaks to kind of my experience with K3s. So I've been working with Kubernetes probably 6 or 7 years now. I've played with different distributions and models, and a lot of them are very heavyweight and fat. So I was doing developer advocacy, trying to convince developers like, yeah, this is why you want to use Kubernetes, but you need 6 nodes in AWS and you can practically hear the bill ticking up as you're running it. And that's a very hard sell to your typical developer who, and I know I'm not talking about edge yet, but I'll get there, I promise. But that's a very hard sell to your traditional developer who's like, I just want to run it on my laptop. They always say like, so I can do it on a plane. I sleep on planes, but that's beside the story. With the edge, well, that's I thought of that one. I actually just popped my stress ball on top of everything else. I'm now covered in sand. So what do we need? We needed something lightweight. It started from this developer setup. The first time I played with K3s, by comparison, it was incredible. I ran a basically single command, and then it just looked at me in the shell, and I'm like, okay. And I cuddle get nodes, and it ran. I was like, oh my God, this is insane. So now let's take that from a development environment, and everyone's like, this is awesome. I can finally do stuff on my laptop or in my home basement. I'm sorry, my home lab in my basement. Nice. But now that's very similar in a lot of ways to your edge environments. You have these lower resources. You don't want to be spending massive amounts of compute power for a coffee shop down the road or something like that. So you want something very, very lightweight, incredibly easy to install. And that's admittedly a loaded statement. I mean, depending on how much tweaking you want to do, you can always overcomplicate it. But really, that lightweight aspect of it was absolutely compelling from the start as a developer standpoint. And then as Edge kind of grew, we're like, this is kind of perfect, actually. This is exactly what we need out there.
Okay. And that makes sense, right? Like my next question focuses around some of those aspects. Like, we have a technical audience for this podcast, so don't hold back. But the question is like, how is K3s, like from a deployment perspective, from an architecture perspective, different from like a vanilla open source Kubernetes or any of the other Kubernetes distributions that are out there?
Yeah, and I'm glad you mentioned this is a technical audience because I could just dive into the easiest one. It is a single binary, about 100 megs. And that in and of itself is really wild because it is able to embed a lot of the core infrastructure you expect to see with Kubernetes inside of this binary. So I alluded to it earlier, but the install at its simplest, and again, this is slightly different for production, but is effectively you download a shell script, you run it, and ta-da, you have K3s. So now we're looking at this single binary with everything inside of it in a default deployment, you'll actually be running SQLite instead of etcd. Obviously, there's scaling issues there. It's the trade-off, right? It's, yes,
Yep.
you don't scale like you would, but at the same time, you're not using the resources you would either. And back to my home lab or Raspberry Pi or my laptop, I don't want to be running a full etcd server, especially if I don't need to. So you have all of this as this package binary, and you can still run it as a systemd service. At the end of the day, though, it is still Kubernetes. Same ports are open, same APIs, same data types, same manifests. So let me be very clear that it's different from K3s and like that architecture standpoint. Actually, let me get back to that for a second. You can still absolutely deploy it multi-node and HA server agent environment. Your vanilla install and the one I would typically run on my laptop or in a CI/CD system is going to be a single node, but there's absolutely the option to set up your HA clusters and everything you would expect out of Kubernetes. It is just smaller and very, very lightweight. And it makes for, it's also as scalable as you would expect it to be. We do have customers running over 1,000 nodes in a single edge cluster.
Oh, wow.
On top of K3s. Yeah. So your gut reaction, any developer is going to look at it and say, particularly the admins, are like, there's no way this single binary is like, this is a cute toy. Yeah, exactly. Yeah. Exactly. I'm sure that was part of my thought initially. Like, okay, this is cute. Like, give me something real. And then you start to look around and you're like, people are using this and they're using it very, very well.
Interesting. Okay, like one of my questions that I had for today was like, how small does the setup need to be? Like, if it's a single node non-HA thing, can it run out like one node, or does it still need like 3 nodes for some sort of HA? But if there are people running 1,000 nodes, it covers the other side of it for sure.
That's exactly right. And you know, when you're talking about the edge, HA is not necessarily table stakes like it is in many environments. We actually have been researching into 2-node HA, which is a bit of an oxymoron in and of itself. But looking at these smaller footprints that don't want a massive HA overhead because they don't need it. You know, I refer to this coffee shop type of model where, like, you know, the world continues to go. That's probably a bad example. If a coffee shop goes down and people can't get caffeine, that is riot worthy. But come with me on this. I'm glad you appreciate that. Everyone's like, what is our mission critical applications? Healthcare? I'm like, it's the coffee people, guys. But yeah, they don't necessarily need full HA at the edge. You have other options for your uptime. You have situations where the uptime isn't quite as critical. And this is, I'm going to pause on this because I'm sure the questions will come back to it. But Edge has such a variety of use cases that HA is not the be all and end all of everything that people need to deploy.
Yeah, HA definitely has like a different meaning when it comes to these edge locations, right? Last year we had somebody from Chick-fil-A on the podcast, and they run like a 3-node Intel NUC based K3s cluster at every one of those Chick-fil-A locations, and they were not just thinking about HA in terms of like the Kubernetes or K3s clusters, but they also were thinking about HA in terms of network connectivity, because still they had like a core environment sitting outside the edge locations, and they're like, if my physical network that I'm paying money for goes out, they had like an LTE fallback on. So like HA definitely has different meanings, different implementations when we're talking about these edge deployments.
Yeah, I love how you put that. Different meanings, different implementations. It's an interesting twist for people who have been preaching HA for years now to start thinking, okay, it's not a data center where we can very easily section things off and have redundancies in our network and power and so forth. It's funny. It's almost, you know, when you think back to early computing in the 70s and 80s when space was at a premium, memory was at a premium, and then we all got really complacent when things blew up and all of my code is fat and ugly and just takes up as much space as you give it. And all of a sudden now we're like, oh crap, we got to go back to these smaller types of setups. And we actually have to start thinking about assumptions we may have made during this boom of extra hardware and say, all right, you know, does this actually apply here?
Yeah, no, I completely agree. I think I've anecdotally heard stories that senior developers or staff developers at organizations just took resources for granted. Like, oh, it's on AWS. Like, I don't need to build my application efficiently. I can just put more resources behind it, and now it's coming back to them, and then they now have to like design the application almost from scratch and make sure that they can keep up without adding a lot of cost underneath it. So
yeah, that's exactly right. For years of my, and this speaks volumes to how lazy of a coder I am, but for years I haven't had to concern about memory footprints because just throw a couple more gigs in there, you're fine. All of a sudden, when you're talking about these nukes and these Raspberry Pis, you're like, everything feels very, very small around here.
Mm-hmm. Okay, so let's talk about what a vanilla deployment for K3s looks like, right? So you said SQLite as that key value data store. What else? Does it have a kubelet? Does it have a control plane component? Does it run as a pod? How do you deploy containers or pods on it, right?
Sure. So for a single node, it acts basically just like that, a single node. So your control plane is intermixed with your user workloads. And again, and I feel like I keep saying this, but in these environments, sometimes that's okay. If you're not too particularly worried about security or your uptime on your control plane, those can traditionally be fine. Talk in terms of something like storage, we've seen options where people will deploy on a single node and just simply use local storage, which, obviously has its limitations. If that machine goes down or if that hard drive falls over, then you're a little bit of trouble. But it's a trade-off you can make versus sending Chick-fil-A a server rack and having a bunch of Chick-fil-A employees be like, what is this thing and why is it 50 degrees in this one tiny room in the entire restaurant?
Can I power my air fryer though?
Yeah, exactly. I still remember early in my career, the first time I walked into a server room, I'm like, why is it so cold in here? And that was the lesson of, hey, heat is a concern. So that's totally an option. There are you have your CNI interfaces. You can plug in your own CSI back, and you can build it up as necessary. But yeah, by default, it will be single node. You deploy your workloads directly into it, and largely just uses namespaces to keep the control plane stuff separate from what you would want to be touching.
Gotcha. And so, we spoke about the single node version, right? But in your conversations with inside the community or with customers, right? Do users usually do it in a single node fashion, or they have the 2-node, the 3-node deployments to have some sort of resiliency at the edge?
Yeah, so the podcast can't see me smiling at that, but I was smiling because we are working on a product called Edge Image Builder, which is meant to build a single image with everything you would need to run a cluster at the edge. So your K3s install, your operating system, the configuration on it, and so forth. And it was considerably simpler to add in single node K3s. And I'm like, can we just ship this? And everybody stared at me. I'm like, okay, fine, we'll add HA. So yes, there is absolutely a need for adding it. The configuration, the setup is actually really, really slick. It's largely just saying this one's a server, this one's an agent. And again, not to trivialize it or downplay its capabilities or the amount of work that went into making it that simple, but it really is very slick when you look at it in that perspective. And yeah, there's absolutely people using it in HA. Even if my dev brain just thinks it's running on my laptop, I don't particularly care. I'm going to keep it up for 10 seconds and then I'm going to, rebuild it because I screwed something up.
Gotcha. Okay. So are there any prereqs that listeners should know about, right? Do I need 4 CPUs or do I need 8 gigs of RAM? From a resource perspective, are there minimum requirements that they should keep in mind? There's
probably listed somewhere some minimum and recommended. What I can say is it's nowhere near that beefy. There are absolutely Raspberry Pi instructions that say the only thing with Raspberry Pis is you have to explicitly enable C groups because it's not by default. But being able to run it on a Raspberry Pi kind of indirectly answers that question because that is this sounds obnoxious. That is a very low bar in a very intentional way. I'm not dunking on Raspberry Pis here, but that is a very low bar. And if we could say, yes, you are capable of running on that, it shows you just how small that footprint actually is. Okay, gotcha. So I know we already spoke a bit about how storage is handled, right? With maybe using local disks, but I'm sure you said, okay, we can package up any CSI based storage provider if we want to, but do you see people storing data at these edge locations for a longer duration of time, or they're just using it as
scratch space, if I don't come up with a better word, but just like keeping it there for a couple of hours and then pushing everything back to the data center or the cloud environment?
Yeah, holy cow, what a great question. And the answer, as with everything with Edge, is it really depends on the use case and the code. It's, man, again, as a teacher, that's such a cop-out answer. Like, it depends. Can you not ask me that again? I do have a real answer, though. So there are absolutely use cases where they do not want to be sending a lot of data across the wire. Either it's going as far as like a satellite connection, or if it's sending a absolutely ton of data. So you've got to figure, we haven't talked about the edge use cases yet, but when you factor in something like IoT and you are measuring readings every second and you're getting all of this data, that across the wire is extraordinarily painful. So having that cached and dealt with at the edge side, and then summaries sent across the wire or some sort of calculation sent across the wire, reduces that bandwidth between your edge sites and your data center. And again, we were joking a couple minutes ago about we've gotten so used to big resources. We've gotten so used to good network connections. And I stream video all the time, and I don't think twice about it, but that's not always the case. So if we can offload some of that to the edge sites, have them deal with a lot of the data, and then send a summary, that is a very viable option. Another concern is data privacy and concerns, where when you start getting into healthcare situations, they don't want to be sending a ton of customer information that violates any number of 4-letter acronyms out there that you're not allowed to send data across. So can we do the calculations on the edge side and then send across the net results or some kind of summary, some kind of status? And all of that is outside of any kind of air gap situation where you're talking about government, defense, things like that, where they straight up don't have the ability to send it back or don't want to for whatever reason. So the answer is yes to all of them. The important takeaway here is, again, that mentality shift of resources are suddenly becoming finite again in a very weird way at the edge. And it's a callback to 20, 30 years ago that you have to consider that network pipe. And maybe it doesn't make sense to shove everything across the wire. Maybe Edge does hold on to it and have its own security policies, obviously, but then it's able to do its calculations, its summaries, and send across a smaller report or an interval-based report or an emergency report of, not going to say anything unless something is wrong, in which case then it's going to start yelling back to the data center.
Gotcha. Okay, interesting. And you brought up data privacy, right? Which, like, I think it's a perfect segue for the next question that's focused around security. Like, how do I make sure that I don't expose those API server endpoints from all of these edge locations? That's just being one of those concerns, right? Like, how do I secure my K3s clusters? Because ideally, I might have like tens or hundreds or if not thousands of these different edge locations that I have to manage remotely. How do I make sure I'm securing each one of those?
Yeah, and I love the fact that you went to that scale. I think that's the scale we need to be thinking at with Edge of the tens of thousands. K3s has that baked into it. It is hardened. We're working toward FIPS compliancy. It is secure just by default. And then if you look at the entire suite or the entire solution, you put that on an operating system that has also been tailor-made to be secure in these situations. Something like SLE Micro, which is a immutable file system and built to be lightweight and also secure and try to prevent some of these situations. You've started to realize the entire solution from the ground up really has to be architected with that in mind, particularly as laws get more and more strict about this stuff. And let me be very clear, rightfully so strict. That's certainly not a knock on them. But as that starts to happen, you realize, hey, it's a little more than just, can we send this over SSL and be done with it? So on top of that, you have other abilities, something like NewVector that comes in and is a security platform doing runtime enforcement, doing your container image scanning and so on and so forth. You have your network policies that you can implement just like you would on a normal Kubernetes structure, cluster. So at that rate, you're looking at, and this goes all the way back to the very beginning, right? Like using a Kubernetes-based distro gives us that option to use this wide ecosystem of products. Or you look at a solution like what we're pitching with our Edge product of, hey, here are all these products working together and answering these types of particular questions, because you were absolutely right for asking them. These are very, very valid questions that we keep joking about the resource differences, but it's also the where the data lives. And suddenly that's a bigger deal of Chick-fil-A is a great example. Like, something tells me that's not quite as secure as your traditional data center. I'm going to say that's a pretty safe guess.
Yeah, you can't have bodyguards or restrict people to physically access your Chick-fil-A location.
That's right. Now when you got to get the employee there to go bounce the server or something like that, it doesn't really work that way.
Yeah. Okay, so like when you talk to a lot of people, right? These are definitely great things that people should keep in mind, but are there like security best practices that you tell them like, okay, these are the common issues that I have seen. Please fix this and then think about everything else. Like, are there any low-hanging fruits you want to share?
Low-hanging fruits, let's see. Don't make your root password. Just you can write that down if you want. We'll send out the list. No, honestly, to be perfectly honest, this is slightly outside of my area of expertise. So I don't want to drive people in the wrong direction. So I'll kind of simply reiterate, the tools are out there. You look at the CNCF landscape in general, and there are a number of players in this all addressing these. So if nothing else, knowing you have to ask those questions is the really important part, because there are the answers out there. That part of this part of the solution is there, where multiple people playing and we understand. And I guess I can provide a summary of you want your containers to be scanned themselves. That can go all the way back to your SBOMs and your the other term related to SBOMs, the whole accountability of all your artifacts going into your builds, your network security. There are platforms and plugins for that. Your operating system is still potentially a vulnerable vector if you were to go and pick some generic open source Linux distribution that is not meant to be hardened by default, or they never intended it that way. So,
like, don't assume that it will be. Like, agree.
Yeah. You know, I'm sure there's people out there who are like, oh, well, Linux, it's not, I feel bad saying this, I probably shouldn't, but like, oh, it's not Windows, Linux is fairly secure. Yeah, well, there's another level of that. So realizing the different touch points that you have to be cognizant of, choosing a secure version of Kubernetes that has actually had this hardening on top of it, all of that factors into it. So in terms of low-hanging fruit, the biggest thing to realize is just there are a lot of areas to consider, and there are solutions out there, and there are companies like SUSE who are putting these solutions together and saying, and I'm sure many of the listeners here have seen the CNC landscape page with, last I checked, we're at 30,000 icons on it. It actually crashed my machine last time I opened it. Having someone to guide you through that and say, we have tested this particular combination and we stand behind it. That is absolutely crucial, because no one has the time to go through that landscape image, much less test them out and come up with their own decision.
I know, and that's the thing that I like, right? Like the CNCF is open, like full of possibilities, but do you really want to spend the time and figure out how these things interoperate with each other and which is the best one in each layer of the stack? So yeah, I like that you said, like, there's a vendor out there who will support all of these things for you.
Yeah, we've done the research, we've done the integrations, and I love using that landscape diagram as it's a pro in so many ways. Shows the living ecosystem, shows the investment, and at the same time, if it scares you, that's a good thing, because it kind of should. It doesn't mean it's going to be easy just because there's choice.
Oh yeah, I think the only fair use I see for that CNCF landscape is either like to scare people for a vendor solution, or put it on like that huge screen that they do at like KubeCon keynotes. Like, that's when those logos are actually visible, Jason.
That's right. That's the only time you can see one without zooming in like 1,000%. And you're right. I have, in my developer advocacy days, absolutely used that as a scary thing. I'm like, you think this is good? It is, but have fun. That's my answer when everyone's like, you work at an open source company, how do you make money? Take a look at that picture, pick a couple, and you let me know if you want to pay me or not.
That's awesome. Okay, so next question is more around like the manageability and day-to-day operations, right? Like, is there a way it can be like an open source solution, or it can be like a solution from SUSE. Like, is there a way to manage all these remote K3s clusters from a single pane of glass where I can apply the same policies, I can monitor everything together? Like, is there a solution out there?
Yeah, I'm I'm laughing because this is so much of like the bane of my existence is figuring out the single pane of glass. Let me talk about why this is so funny to me, because we mentioned a couple minutes ago thinking in the scale of 10,000 edge nodes. Visualizing that and finding a way to show this information in a consumable, useful way is a very non-trivial answer. I mentioned at the outset that a lot of this is blazing new territory, and scale is absolutely one of them. That we are looking at these massive tens of thousands of machine deployments. Single pane of glass there, I mean, just between the two of us, trying to picture that, much less implement it, is a little bit fuzzy. At SUSE, we are incredibly lucky to have the Rancher project. Rancher is fantastic at this. And it is one of the reasons why our Edge department has seen the success it has, is because we have this kind of strong integration. We have this strong backing of SUSE Manager and Rancher, and this ability to manage large machines at scale. And what a couple of my coworkers on the Edge team are working with is, okay, how do we visualize that? And that is still a very much evolving answer. But the question is extremely valid because, and I tell my students this all the time. First thing I do in like the beginning of classes, I was like, you guys have a laptop, maybe a gaming PC, maybe your mom and dad's PC, you help them admin. That gets an update. We reboot it. We go get a coffee and come back and it's done. I was like, that's not an option anymore when you look at this scale. You don't just press a button and walk away and say, yeah, I'm sure it's going to be fine. So using something like Rancher and using the extension mechanism in there to add on these extra features and using the edge work that we are doing to be able to visualize and kind of federate that entire approach is absolutely crucial because, again, sure, open source, you could potentially put that all together on your own, but why do that when you have someone focusing on it and you can leverage that and then use that to do your 10,000 deployments?
Okay. No, I think that's a valid answer, right? But okay, sorry, I'm going off script here. I want to make sure that I'm asking you this question. So how do I, can you share some of the customer stories, right? How are they actually using this in the real world? Like we have some examples already on our existing episodes, but like, can you share a few examples from customers that you work with that are using these technologies, right? And you don't have to name names if you don't want to, but I just want to like see or hear more stories about this thing in real life.
Yeah, I'm trying to filter out in my head so I don't get in trouble. This is where me being a tech nerd, I'm very, very scared. You just say customers, I'm like, I can't talk about that. I think it comes down to considerations you want to take in mind in terms of things like rolling deployments, things like Canary. And I know I'm saying things that you guys have come across before, but at the end of the day, each customer solution has its own kind of unique spin on things because everyone's got their own unique sets of problems. I've alluded to a lot of the different areas of edge when you range from healthcare to military to cars to IoT. All of those are going to end up doing their own thing. Some of it is managed from more of a central location where you do have this rancher and you're pushing things out.
Gotcha.
There are plenty of other options, especially when you get into air gap. That entire answer becomes different because now you are walking around with a USB key. The important part is really comes down to the customer understanding their particular needs. And at that point, that's where I hesitate to say anything more beyond kind of generics because I don't want to tip my hat at like, so-and-so
XYZ is
government does this. Yeah.
Yeah, I don't think we have that wide of a listener base where we have like malicious actors listening to this, like, oh, let me find out which organizations are using the stupidest solution. No?
But at the same time, I am also not clever enough to hide them correctly. So like some government with a red, white, and blue flag is doing I'm just kidding. I'm not saying anything with the US government.
That is funny, dude. Okay, no, that works, right? I think we all know, even there are examples on like CNCF's website and K3s's official site that lists some of those customers out there. So there are people using this in the real world for sure.
There are. And I would even say, to continue to plug SUSE, we have those customer stories out there as well, written by people with lawyers looking over their shoulders to say that they're saying the right thing. Yeah, safer to read those.
Okay. Let's do a pivot, right? Like, I think this discussion has been great, but I wanted to talk about AI, and like that's one of the new questions that we have added in 2024. Like, ask our guests, like, how are you thinking about AI? How do you see AI being used in a good way? You can also share a bad way if you want to, but think about share some of the use cases. So if our listeners are just focused on ChatGPT as the definition for AI, they come across different ideas and different thoughts on how we can explore more of these options.
Yeah, and I'm going to answer this from more of the professor hat, because this has, in the past 2 years, so I've been teaching effectively for 15 years. I took a little bit of time off when my kids were born, but only in the past 2 years has the university have to sit there and say, okay, guys, we have to pay attention to this AI thing now. So it's been kind of fascinating to me because I am in my mid-40s. My students are in their early 20s, late teens. So there is enough of a generational gap there where it's almost ingrained with them already. Much like my kids from age 6 understood really how to use an iPhone and navigate that, as compared to my generation didn't struggle much. But you see where I'm going with this, is that, this was foreign technology for a while. I have noticed these younger kids, these college kids, just diving into it. I had one specifically ask me at the start of the semester 2 weeks ago, like, can we use AI in this class? I'm like, I don't actually know what that means, but I'm probably going to say no because I don't trust it. But at the same time, I had a student once, actually, he's a coworker now. I asked him, I don't even know if I asked him specifically, but I was like thinking out loud in Slack, and he like pasted me this command, and I was like, holy, this is exactly what I wanted to do. And he's like, yeah, I just asked ChatGPT that. That's kind of wild. It has affected how I craft my class, because I imagine probably a good 95% of the people listening to this have solved Towers of Hanoi in code. Every language imaginable. Probably someone did it in Minecraft. So you suddenly can't ask generic questions. You have to get really tricky with the programming assignments and make it intentionally slightly vague and something no one's ever seen before. But there have been times when I've absolutely let them embrace it when it makes sense. So I had actually one of the cooler senior projects that I had one of my students do. He used KubeVirt to spawn up virtual machines dynamically. The idea was, it was a 3D space where you are doing an escape room. And you go up to a computer and you turn it on. And this, again, like a 3D JavaScript space. And the computer itself is backed by a KubeVirt VM, thank you. Running on top of, I believe, K3s, actually. It was definitely the SUSE suite. And you interacted with that and solved puzzles in there, and effectively, air quotes, hacked it to figure out the solution to escape the room. Now, as part of that, some of the assets he used in there, he just straight up used AI to generate. And I would have never have known if there was two reasons. One, he told me, he was very clear about it. But number two, the only weird trick is the word basket was in the title for one of them, and it had 2 Ks. But it was in this image that was generated that the image was so nice. It was an entire node-based site, very simplistic, but I had no idea if he hadn't told me. So I guess this is a slightly bad take on it, in the sense of this is becoming more and more difficult from the university perspective. Like, how do I get my students to actually write their papers versus get AI to do it? And it's not quite as simple as you would think, because I've had some very poor writers and the AI sounds a bit better. You're almost like, you know what, just use AI next time, please. I don't want to grade this again.
No, I agree, right? Like I didn't think about this before, but when you brought up the other side, like as a professor, like how do you enforce that students are not using AI?
Yeah.
I don't think there are any tools, even from OpenAI, that have like, oh, this content was generated from AI or any, like I know when I went to school, there was some libraries that professors used to make sure that this is not plagiarized and it's not just picked up from the web. I don't think that sort of thing exists for AI generated content yet. So it is difficult. Wow.
No, that is exactly right. So we have the system that we handle basically student interactions within grading. Yeah. It will automatically check papers for exactly what you mentioned, looking whatever it does in the back end. None of it is equipped for AI yet. Taking this all back to Edge, looking at the possibilities of, and this goes a little bit back to my idea of, we have all this data sitting on the edge and we don't necessarily want to send it back. If you're in that kind of limited communication spectrum of Edge, think not even necessarily air gap, but think military, where you don't have a Ethernet plug to plug in and you're very bandwidth constrained because of satellite or because you're a submarine or something. Being able to do much more of that processing on the edge side and having AI assist with that is completely fascinating, because now we have our ability to administer these systems remotely and do everything we need to do in terms of upgrade and uptime, but letting them start to handle more and more of it at the edge and dynamically adapt without the need to call back into the data center and say, here's my 3 terabytes of data, figure out the best way of doing this. Those can start to learn on the edge systems. And I think that's really going to get fascinating, continue to push us away from the model we've gotten into in the last 20 years of everything sits in a awesome looking data center with all these blinky lights. And I say that every data center I've ever seen has had wires hanging from the ceiling, an actual box fan set up somewhere. Dead mouse
I just
in
had
the corner.
to confess, like last week to my teammates, that I was a shitty, like, wiring guy. Like whenever I worked in a data center, like they were talking about how pristine their cabling looks, like, oh, they have zip ties everywhere, and like, oh no, you shouldn't look how I work, or you shouldn't see how I work in a data center environment.
Exactly. I tell my students that too. I was like, it looks so cool in movies, and I'm like, and then you get there in real world and there's a sticky note that says, do not press this button, the entire company will end.
Yeah.
And I know that because I'm the one looking at the button going, God, I really want to press it and see what happens.
I know, like, see what happens, right? Yeah. No, I think that was a great response to our question about like how to think about AI. That definitely like opened up some possibilities or some thoughts at least. I want to, as you said, right, bring it back to the K3s discussion. How can people get started? How can they contribute to the community? How can they learn more or experiment or get their hands dirty with K3s? Any recommendations?
Yeah, and I love that phrasing, the hands dirty, because like I said at the outset, this is one of my favorite things about K3s is that if you are brand new to Kubernetes and starting to figure it out, K3s is such a great avenue for that because it is so low resources. So K3s.io, that is going to be, you know what? Hang on, let me double check that. Let me make sure I didn't say that. K3s.io. It's one of those things that I've typed once and autocomplete the rest of it. Yes.
Yeah, it is. Yeah.
I am correct. K3s.io. That would be embarrassing. Is kind of our landing page for it. And that is going to have your traditional why use K3s and so forth. But you will notice in the top right of that page, there's a basically curl bash command that is literally all you need to do. Copy and paste that running on your machine. From there, you can find links to the community. It is an open source project. It has actually been donated to the CNCF. So you have all of those resources available you would with every other Kubernetes project. This isn't a SUSE in-house type of thing that we're like, no, stay away. It is very much open. We are very much an open source company. And it is so lightweight that the hardware, it runs on, I should also be clear, x86 and Arch64. So you've got your nice shiny new Mac M1 that doesn't run 40% of the things you're used to because they're not x86. K3s will in fact run though, and if it sounds like I'm has some PTSD from that, it's completely true because it's been an interesting couple of years working on them. But all of that is supported by K3s. So K3s.io is a great starting point. From there, you will find everything from GitHub to community links and plenty of people to interact with. And then in terms of getting your hands dirty, I genuinely believe that is the best way. I've had students use it for their senior projects, and wow, this is very difficult to say without sounding obnoxious, but they are not the most technically savvy at that age. So being able to say, yes, they were able to install K3s is a lot bigger deal than it probably sounds like.
No, dude, like, trust me, like when I was at school, like I was doing my master's, somebody just gave me like an ESXi ISO and they're like, yeah, go and install vSphere and like get a VMware environment up and running. And I had no clue. Like, I was like, what do I do? You gave me a USB and pointed me to a rack full of servers. Like, what's next? Yeah. So agreed. Like, this is a learning experience, and a curl command is definitely way easier than installing ESXi. I will definitely take that.
Yeah, once you get over, and it's funny because for the younger, less experienced engineers, that's absolutely easiest. And then you have your occasional admin who's like, are you really expecting me to run a curl bash on my machine? You're like, that's a very fair assessment. Check the documentation. It's going to give you some more information.
Awesome. Okay, no, Jason, like this has been an awesome conversation. Like I'll make sure I'll include all of those links, some of the sessions that I found useful while doing some research. I'll make sure that I link to your LinkedIn page. If you have any other ways people can reach out to you, let me know, and we'll put that in the show notes.
Yeah, LinkedIn is best for now. Happy to engage anyone who wants to talk about it or just generally talk nerdy stuff. This was a blast. Thank you for having me. Like I said, it's been a long time since I've got a chance to nerd out and just laugh about this kind of stuff. And this was really cool.
Yeah, thanks so much. That was a great episode. I love how you focus not just on K3s, but also how his students at Villanova University are using artificial intelligence and how the professors are just trying to keep up and advising students on when and when not to use Gen AI technologies. But going back to key takeaways, specifically focused on K3s, I like the point where I just want to reiterate the point that Jason brought up, right? Like the security hardening work that has already been done, the workflows that have already been built, the CI/CD automation, the API, the ability to interact with the Kubernetes API, the familiarity that all of us have with Kubernetes inside our data center or cloud environments can now be extended to the edge, just because we have something, a very small footprint, like 100 meg footprint solution like K3s available in the ecosystem. So K3s can be used not just as part of our CI/CD pipelines as that lightweight Kubernetes compatible distribution, but also at these edge locations. And one thing that caught my eye, or I really liked, was how Jason wants us to think about high availability in a different way when it comes to these edge environments, right? Again, if you are an admin that is already responsible for architecting these edge solutions, this might not be new to you, but it was definitely new to me that HA is not really a strict thing that people have to follow. Like the definition for high availability and resiliency at the edge can definitely change and can be different from organization to organization, from edge location to edge location. So from things like just the ability to run a single node server, but then making sure that it always sends the summary of all the data that it has accumulated and analyzed back to the data center. That's okay, but there are situations when you can scale up solutions like K3s to a 3-node deployment with maybe an etcd, if not a SQLite instance, run your CSI plugins, have persistent data at those edge locations. That is possible as well. So I think this discussion more evolved into like the art of possible, right? Like what can we do with K3s, or what else can we do with K3s? So I think I would like to just keep that in mind when thinking about these edge solutions. Again, thank you for giving us the feedback, and so we can always improve our content. Let me know if there are any other episode suggestions that you might have. You can reach out to me directly through LinkedIn, Slack, Twitter, any of those social media channels. If not, maybe in person at some conference, right? But I think that brings us to the end of today's episode. Before we sign off, I want to make sure that I reiterate, please give us 5-star ratings on the podcast app that you use to listen to our podcast, or hit subscribe and like, and share the episode on YouTube if you watch us on YouTube. This brings us to the end of another episode. I'm Bhavin, and thank you for joining another episode of Kubernetes Bytes.
Thank you for listening to the Kubernetes Bytes podcast.